So we'll see seafloor spreading theory. So if we talk about the origin of the theory, so initially what happened was that before World War II, nobody knew that what kind of structure beneath the ocean is. So this is ocean and this is the structure. So people used to assume that the ocean, the surface beneath the ocean is flat. But when in World War II the submarine started to go downwards, then they saw that they made few observations. So what were these observations? So the first observation was that the ocean floor is not flat. So this was the first observation, and the second observation was that there are some active trenches region with high heat flow. So in oceans there are some trenches. So trenches is the lowest surface part where the oceanic plate subducts. So this is the surface part on the crust which is formed, that is called the trench. So the second observation was there are some active trenches with high heat flow, and underwater mountains are there, and the rift valley along the crust. So there are in the oceans there are some rift valleys also there. So this is the second group of the observation. The third observation was when we go away from the mid-oceanic ridge. So suppose this is the mid-oceanic ridge. When we go away from the mid-oceanic ridge, then we find that the ocean crust is older compared to the mid-oceanic ridge, whatever the crust here nearby the mid-oceanic ridge. And the fourth point was that nowhere uh, the ocean is older than Mesozoic time, which is 180 million annum. So nowhere the ocean is older than one, means whatever the ocean before one oceanic crust before 180 million years was, that has been uh, recreated. Now what does the seafloor spreading theory say is that seafloor spreading theory says that suppose this is the earth and this is the oceanic crust, then there are some convection current going on. So what does these convection current do? This is going this side. These convection current puncture the crust. So under the oceanic floor, in the mantle, vertical convection currents are there, and these convection current puncture the crust, and these are the limbs which are created after the puncture, and these are traction dragged. So traction is created because of the uh, convection current, so that moves away the sea floor, and the magma comes out, and that forms the mid-oceanic ridge. So mid-oceanic ridge are formed because of the convection current. There are two type of mid-oceanic ridge: fast and slow. Slow mid-oceanic ridge, that is less than 2 centimeter per year, and faster greater than 2 centimeter per year. So these are two mid-oceanic ridge. Then there is progressive formation of new volcanic rock at the mid-oceanic ridge. So as the magma come out, the new volcanic rock will be formed, and the which and the limbs are traction dragged and keep on moving away. The different rate of operation of the convection current, ocean may be dragged relative to other part, and transform form faults are formed. Again, the mid-oceanic zone of the ocean crust creation, so that there has to be a zone of destruction of the. So when at the mid-oceanic ridge the crust is created, so somewhere the destruction zone should also be there. So suppose this is moving in this direction, so here it will form the trench. So trench are the zone of the descending limbs and the subduction. So suppose this is the continent, and there is subduction going on. If there is subduction, then here is spreading going on, and again here will be subduction going on. So again, this is continent, this is continent, this is ocean, this is ocean, and these are the vertical convection current which are causing the traction drags. So this is what the seafloor spreading theory is.